Hello everyone, today we're going to talk about the element arsenic. Arsenic is element number 33. So arsenic doesn't melt, it sublimes when you heat it. It's basically metallic nitrogen. So sublimation is a phase transition. Sublimation is the transition of a substance directly from the solid to the gas state without passing through the liquid state, according to Wikipedia. So here's arsenic. Arsenic is famous as a poison. Its molecular formula for that is As4O6. Do not use it as a poison. Here are various cases in history that have unfortunately occurred due to arsenic being utilized as a poison. Here is the formula. Arsenic combined with nitric acid creates rusty arsenic, which is As4O6, and rusty hydrogen, which is H2O, and nitric oxide, which is NO. And this is the balanced formula. Arsenic is essentially, again, metallic nitrogen. Continuing on, here's how As4O6 looks like. And here's another article of poisoning with arsenic. It's a trial for murder. So luckily in the early 19th century, a test was developed called Marsh's test to test for arsenic. It involved combining zinc with sulfuric acid to create hydrogen gas and zinc sulfate. So if there was any arsenic, you would place whatever you think has arsenic along with the hydrogen gas that's being created due to the sulfuric acid reaction, and you would create a new compound called arsine gas. Its molecular formula is ASH3, and when you heat it up, and here are the steps. So first you mix zinc with whatever you're testing arsenic for. You react that with sulfuric acid. Its molecular formula is H2SO4. I previously made a video for sulfuric acid. It's called oil of vitriol. Explained in 8 minutes or less if you're interested. Here's a molecular formula for arsine. It's a chemical compound. Arsine is an inorganic compound with the formula ASH3. This flammable, pyrophoric, and highly toxic pentagen hydrate gas is one of the simplest compounds of arsenic. Despite its lethality, it finds some applications in the semiconductor industry and for the synthesis of organoarsenic compounds. Its boiling point is negative 80.5 degrees Fahrenheit or negative 62.5 degrees Celsius. Its molar mass is 77.95 grams per mole. Its formula is ASH3. Again, its name is arsine, a poisonous gas smelling slightly of garlic made by the reaction of some arsenides with acids. So the arsine gas, you burn it if the arsine gas is produced, which indicates that there's arsenic present. It combines with the hydrogen from the sulfuric acid. If the flame is colorless, there is no arsenic present. It's just hydrogen gas. If the flame is a lavender color, then there is arsine gas. Its molecular formula is ASH3, and there is arsenic present again. So here's a continuation of the molecular formula that I previously presented with arsenic nitric acid to create arsenic oxide with water and nitric oxide. Here's arsenic. Arsenic is a chemical element with the symbol As and atomic number 33. Arsenic occurs in many minerals, usually in combination with sulfur and metals, but also as a pure elemental crystal. Arsenic is a metalloid according to Wikipedia. Its symbol is As. Its electron configuration is Ar. 3d10, 4s2, 4p3. Its atomic number is 33. Its atomic mass is 74.9216 U. Its electronegativity is 2.18. Its discoverer is Albertus Magnus. So here we have nitric acid. Nitric acid is a chemical compound. Nitric acid, also known as alkyl fortis and spirit of nitre, is a highly corrosive mineral acid. The pure compound is colorless, but older samples tend to acquire a yellow cast due to decomposition into oxides of nitrogen and water. Most commercially available nitric acid has a concentration of 68% in water according to Wikipedia. Its formula is HNO3. Its IUPAC ID is nitric acid. Its molar mass is 63.01 grams per mole. Its density is 1.51 grams per centimeters cubed. Its boiling point is 181.4 degrees Fahrenheit or 83 degrees Celsius. Its pH level is 1.2 according to storemassa.com.au. Continuing on, here's arsenic oxide. As you can see, we have the molecule here. The red represents the oxygens and the purple represents the arsenic atoms. And that's how it looks like in a 3D configuration. Continuing on, here we have water. Water is an inorganic, transparent, tasteless, odorless, and nearly colorless chemical substance, which is a main constituent of Earth's hydrosphere and the fluids of all known living organisms. It is vital for all known forms of life, even though it provides no calories or organic nutrients, according to Wikipedia. Its boiling point is 212 degrees Fahrenheit or 100 degrees Celsius. Its molar mass is 18.01528 grams per mole. Its density is 997 kilograms per meters cubed. Its formula is H2O. Its melting point is 32 degrees Fahrenheit. Its IUPAC ID is oxidane or water. color. Here we have nitric oxide. It's medicinal. Nitric oxide is a colorless gas with the formula NO. It is one of the principal oxides of nitrogen. Nitric oxide is a free radical. It has an unpaired electron, which is sometimes denoted by a dot in its chemical formula. According to Wikipedia, its formula is NO. Its IUPAC ID is nitric oxide. Its molar mass is 30.01 grams per mole. Its classification is radical. Its more general ingredient is nitrogen. Its molecular mass is 30.0 grams per mole, according to ScienceDirect.com. So this is how to make the white powder. It's not recommended. This is just for informational purposes. And again, the reason I'm providing this free content is to help everyone understand the natural world around them better, rather than use it to hurt people in the natural world. Continuing on, here we have nitric oxide. Sometimes it decomposes into nitric oxide. So nitric oxide, again, as previously discussed. I'm going to continue on with oxygen because I previously discussed it. Oxygen is a chemical element with the symbol O and atomic number 8. It is a member of the chalcogen group in the periodic table, a highly reactive nonmetal and an oxidizing agent that readily forms oxides with most elements as well as with other compounds. Its symbol is O, according to Wikipedia. Its atomic mass is 50.999 U. Its atomic number is 8. Its electrons per shell is 2.6. Its electron configuration is He, 2s2, 2p4. Its electronegativity is 3.44. Here we have nitrogen dioxide, which it decomposes into, which is why we have aqua fortis, or nitric acid, sometimes looking this color because of the decomposition that it undergoes into nitrogen dioxide with the oxygen in the air or other various oxides. So nitrogen dioxide is a chemical compound. Nitrogen dioxide is a chemical compound with the formula NO2. It is one of the several nitrogen oxides. NO2 is an intermediate in the industrial synthesis of nitric acid, millions of tons of which are produced each year for use primarily in the production of fertilizers. At higher temperatures, it is a reddish-brown gas, according to Wikipedia. Its molar mass is 46.0055 grams per mole. Its formula is NO2. Its boiling point 69.8 degrees Fahrenheit or 21 degrees Celsius. It's also soluble in water. Small amount of arsenic and lead alloys hardens them for use in batteries and cable sheathing. So here we have arsenic and lead. Arsenic, as previously discussed, arsenic element number 33, and lead. Lead is a chemical element with the symbol Pb and atomic number 82. It is a heavy metal that is denser than most common materials. Lead is soft and malleable and also has a relatively low melting point. When freshly cut, lead is silvery with a hint of blue. It tarnishes to a dull gray color when exposed to air, according to Wikipedia. Its symbol is Pb. Its atomic mass is 207.2 U. Its melting point is 621.5 degrees Fahrenheit or 327.5 degrees Celsius. Its atomic number is 82. Its electron configuration is xenon, 6s2, 4f14, 5d10, 6p2. Its electrons per shell is 2, 8, 18, 32, 18, and 4. So here we have lead hydrogen arsenate. It's a chemical compound. Lead hydrogen arsenate, also called lead arsenate acid, lead arsenate, or La chemical formula PbHASO4, is an inorganic insecticide used primarily against a potato beetle. Lead arsenate was the most extensively used arsenical insecticide according to Wikipedia. Its formula is PbHASO4. Its chem spider ID is 17618180. Its UN number is 1617. Its molar mass is 347.1 grams per mole, -1. It's used in batteries and cable sheathing. So small concentrations of arsenic improve the corrosion resistance of thermal properties of copper and brass. Copper is used in common day things such as wires, and brass is used in everyday things such as brass instruments. And here we have an image of copper. So essentially copper and zinc is improved by arsenic. So copper and zinc are improved, and here's an image of arsenic. Arsenic again is element number 33. It's a metalloid. Combination of copper and zinc produce brass is just another fun fact. So elemental arsenic is also used in bronzing and pyrotechnics. Very highly purified arsenic finds applications in semiconductor technology, where it is used with silicon and germanium, as well as in the form of gallium arsenide, GaAs, for diodes, lasers, and transistors. So here we have an arsenic atom surrounded by germanium atoms used to make transistors and photovoltaics and diodes and LEDs and other things such as photovoltaic panels and other things such as solar panels, which another name for solar panels is photovoltaic panels. Here we have arsenic surrounded by silicon, and here we have phosphorus surrounded by silicon. We could use phosphorus or arsenic as the alternative, and we can use silicon or germanium as the alternative. Either one works. So what is doping? To increase electron or hole concentration. So we have donors, column V elements, add more electrons. So we have phosphorus, arsenic, we have antimony, we have boron, gallium, indium, and aluminum. So the donors are phosphorus, arsenic, and antimony, and the acceptors are boron, gallium, indium, and aluminum. So here we have diodes. So we use arsenic, germanium, silicon, phosphorus to make diodes. A diode is a two-terminal electronic component that conducts current primarily in one direction. It has low resistance in one direction and high resistance in the other, according to Wikipedia. So this This is the diode. So here we have lasers. A laser is a device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. The word laser is an acronym for light amplification by stimulated emission of radiation according to Wikipedia. So here we have transistors, another thing that arsenic is essential in. So again, arsenic is useful in transistors, lasers, and diodes. So what is a transistor? A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. Transistors are one of the basic building blocks of modern electronics. It is composed of semiconductor materials, usually with at least 3 terminals for connection to an external circuit, according to Wikipedia. So among the most important commercial compounds are the oxides, principal forms of which are arsenic oxide, As4O6, and arsenic pentoxide, As2O5. Arsenic oxide, commonly known as white arsenic, is obtained as a byproduct from the roasting of the ores of copper, lead, and certain other metals, as well as the roasting of arsenopyrite and arsenic sulfide ores. So here we have arsenopyrite. Arsenopyrite is an iron arsenic sulfide. It is a hard metallic opaque steel gray to silver white mineral with a relatively high specific gravity of 6.1. When dissolved in nitric acid, it releases elemental sulfur. When arsenopyrite is heated, it produces sulfur and arsenic vapor, according to Wikipedia. Its optical properties are anisotropism or strong red. Its crystal class is prismatic. Its crystal system is monoclinic. Its color is steel gray to silver white. And here we have arsenic with sulfur, and that's how it looks like. Arsenic is concentrated in magnetic sulfides and iron ores, most commonly associated with sulfide and oxide complexes in soil and rock formations. Some of the more prominent arsenic-bearing materials include orpiment, As2S3, relgar, a little s, capital S, arsenopyrite, FeAs, capital S, and gaudorite, FeAsO4, 2H2O, according to Bison and Firmo, 2003. So here we have an image of lead and copper. So transistors, here's just more information on transistors. Here we have 2 types of transistors. We have PNP and an NPN junction. PNP simply means that it's a positive, which means that it's relatively more positive here, which means it has less electrons here and more electrons here, and here it has more electrons here and less electrons here. And this is how they differ. And these are used in computers and in this iPad that I'm using to record this. So continuing on, here we have arsenic. Arsenic was the poison of choice until its detection became easy. Few people have ever seen its rare yellow form, which is reportedly obtained by rapidly cooling As4 vapor in liquid nitrogen. The trouble is that yellow arsenic is light sensitive, converting instantly back to the typical gray form when illuminated, tricky to film. So arsenic oxide provides the starting material for most other arsenic compounds. It is also utilized in pesticides and serves as a decolorizer in the manufacture of glass, silicon dioxide, and as a preservative for hides, which is animal skin. So arsenic pentoxide is formed by the action of an oxidizing agent, e.g. nitric acid, on arsenic oxide. So here we have arsenic trioxide. Arsenic trioxide, sold under the brand name Trisenox, among others, is an organic compound and medication. As an industrial chemical, it is used in the manufacture of wood preservatives, pesticides, and glass. As a medication, it is used to treat a type of cancer known as acute promyelocytic leukemia, according to Wikipedia. Its formula is Sa2O3. Its molar mass is 197.841 grams per mole. Its solubility in water is 20 grams per liter, 25 degrees Celsius. Its drug class is an antioplastic agent. Its boiling point is 465 degrees Celsius or 169 degrees Fahrenheit. Its melting point is 312.2 degrees Celsius or 594.0 degrees Fahrenheit. And here is how it looks like. As2O5, arsenic pentoxide. Arsenic pentoxide is an inorganic compound with the formula As2O5. The glassy white deliquescent solid is relatively unstable, consistent with the rarity of As5 oxidation state. More common and far more important commercially is arsenic 3 oxide, according to Wikipedia. Its formula is Sa2O5. Its molar mass is 229.8402 grams per mole. Definitions of arsenic oxide: a white powdered poisonous trioxide of arsenic used in manufacturing of glass and as a pesticide, rat poison, and weed killer. Synonyms: arsenic, arsenic trioxide, arsenic anhydride, ratsbane, white arsenic. Type of trioxide: an oxide containing 3 atoms of oxygen in the molecule, arsenic oxide. So here we have a mixture of realgar, As4S4, and orpiment, As2S3. Here we have chromated copper, arsenic-treated wood. It's now banned but still found everywhere, unfortunately. Here we have rat poison, Paris green copper 3. Arsenosenite is equally useful in pigments and rat poison. So here we have the gallium arsenide microwave amplifier. It's what goes onto the microwave. The gallium microwave amplifier, here's another side of it. So last but not least, gallium arsenide. Gallium arsenide is a 3 through 5 direct band gap semiconductor semiconductor with zinc blende crystal structure. Gallium arsenide is used in the manufacture of devices such as microwave frequency integrated circuits. According to Wikipedia, its IUPAC ID is gallium arsenide. Its formula is GaAs. Its density is 5.32 grams per centimeters cubed. Its molar mass is 144.645 grams per mole. Its melting point is 2260 degrees Fahrenheit or 1238 degrees Celsius. Its bond type is covalent bonding according to Britannica.com. And here we have relgar. Relgar is an arsenic sulfide mineral, also known as ruby sulfur or ruby of arsenic. It is a soft sextile mineral occurring in monoclinic crystals or in granular compact or powdery form, often in association with the related mineral orpiment, according to Wikipedia. Its crystal class is prismatic. Its crystal system is monoclinic. Its optical properties are biaxial. On the mole scale of hardness is 1.5 to 2. Its crystal habit is prismatic. Threaded crystals, more commonly massive, coarse to a fine granular ore. So let's continue with the element arsenic. So arsenic was known in the form of certain of its compounds long before it was clearly recognized as a chemical element. Again, a quick review is that it's element number 33 on the periodic table. 4th century BCE, Aristotle wrote of a substance called sandarache, now believed to have been relgar, a sulfide of arsenic. So here we have relgar, and here's just a brief description of relgar. Relgar, alpha arsenic 4, sulfur 4, is an arsenic sulfide mineral, also known as ruby sulfur or ruby of arsenic. It is a soft sextile mineral occurring in monoclinic crystals or in granular, compact, or powdery form, often in association with the related mineral orpiment, according to Wikipedia. Its crystal class is prismatic, its crystal system is monoclinic, its optical properties is biaxial, on the Mohs scale of hardness is 1.5 to 2, its crystal habit is presented below, its colors are orange, according to colorlex.com. So continuing on, here we have the relgar mineral data. Its chemical formula is As sulfur, arsenic, and then sulfur. Its molecular weight is 106.99 gm. In the molecular formula As capital S, arsenic, it's 70.03% arsenic and 29.97% sulfur. So let's continue on. So in the 1st century CE, the writer Pliny the Elder and Pedanius Discordis both described aura pigmentum, a substance now thought to have been the dyestuff orpiment, or As2S3. So here at Pedanius Discordis, he's a physician. Pedanius Discordis was a Greek physician, pharmacologist, botanist, and author of De Materia Medica, a 5-volume Greek encyclopedia about herbal medicine and related medical substances that was widely read for more than 1,500 years. He was employed as a physician in the Roman army, according to Wikipedia. He was born in Anaxarabus, Turkey. His other names are Dioscurtis. He's known for the Materia Medica, and he died in circa 90 AD. So as we were mentioning orpiment, here we have orpiment. Orpiment is a deep-colored orange-yellow arsenic sulfide mineral with the formula As2S3. It is found in volcanic fumaroles, low-temperature hydrothermal veins, and hot springs, and is formed both by sublimation and as a byproduct of the decay of other arsenic mineral relgar, according to Wikipedia. Crystal class is prismatic. Its crystal system is monoclinic. Its optical properties are biaxial. Its color is lemon yellow to golden or brownish yellow. Its streak is pale lemon yellow. Its cleavage is perfect on, imperfect on. Its lustrous is rheneous, pearly on cleavage surface. So later, Nicolas Lemery, a French physician and chemist, observed the formation of arsenic when heating a mixture of the oxide soap and potash. So here we have potash. So what is potash? Potash includes various mined and manufactured salts that contain potassium in water-soluble form. The name derives from potash, which refers to plant ashes or wood ash soaked in water in a pot, which was the primary means of manufacturing the product before the industrial era, according to Wikipedia. Its symbol is K, according to lentech.com. So here we have the general formula of solid soap, its hydrophobic group and its hydrophilic group. We have hydrogen, carbon, hydrogen, and then we have carbon attached to 2 oxygens, and then it's all bound ionically to the element sodium. So here we have the general formula of liquid soap. We have 3 hydrogen attached to 1 carbon, 2 hydrogens, and that's attached to, again, a carbon with 2 oxygens, and that's ionically bound with the alkali metal potassium. Arsenic was a well-known and unique semi-metal. So here we have Nicolas Ramey, previously mentioned. Nicolas Ramey, he was a French chemist born at Rouen. He was one of the first to develop theories on acid-base chemistry, according to Wikipedia. He was born November 17, 1645, in Rouen, France. He died June 19, 1715, in Paris, France. He's known for acid-base bonding. His children are Louis Ramey. So the first clearly authentic report of the free substance was made in 1649 by Johann Schroeder, a German pharmacist who prepared arsenic by heating its oxide with charcoal. And again, charcoal is carbon, and the oxide of arsenic can be anything bound with arsenic, such as sulfur or oxygen. So by the 11th century CE, 3 species of arsenic were recognized. White, its molecular formula is As4O6, yellow, As2S3, and red, As4S4. So here we have arsenic trisulfide, As2S3, yellow arsenic is orpiment, and we have here arsenic disulfide, As2S2, we have red arsenic, it's Relgar, and here we have arsenic trioxide, white arsenic, its molecular formula is As2O3. So the element itself was possibly first observed in the 13th century by Albert Magnus, who noted the appearance of a metal-like substance when arsenicum, another name for As2S3, was heated with soap, which As2S3 is 2 atoms of arsenic bound to 3 atoms of sulfur. If you're interested in watching the sulfur video, the link is in the description below. So he combined that with soap. So here's Albert Magnus. So Albert Magnus, OP, also known as Saint Albert the Great or Albert of Cologne, was a German Catholic Dominican friar, philosopher, and bishop according to Wikipedia. He was born in Neuengamme, Germany. He died November 15, 1280 in Cologne, Germany. He discovered arsenic. His place of burial is listed below, and his education is at the University of Paris. Yes, the University of Paris existed all the way back then. He attended from 1243 to 1245. His education is at the University of Paris from 1243 to 1245 and University of Padua. So here we have arsenic and charcoal. Again, charcoal is carbon. So let's continue on with the element arsenic. So arsenic forms numerous organic compounds. Here we have the molecule and its name. Its formula is CH32ASAS CH3. So it's used in preparing the common desiccant, cacodylic acid. Cacodylic acid is the organoarsenic compound with the formula CH32ASO2H. With the formula R2ASOH, it is the simplest of the organoarsenic acids. It is a colorless solid that is soluble in water. Neutralization of cacodylic acid with base gives cacodate salts, e.g. sodium cacodate. They are potent herbicides according to Wikipedia. Its molar mass is 137.997 grams per mole. Its formula is C2H7ASO2. Its boiling point is 487.6 degrees Fahrenheit or 253.1 degrees Celsius. Let's continue. This is the molecule of cacodylic acid. Again, its formula is C2H7ASO2. Here are the 7 hydrogens, 1, 2, 3, 4, 5, 6, 7. Here are the 2 oxygens, 1, 2. Here's the 1 arsenic, and here's the 2 carbon atoms. Let's continue. So several complex organic compounds of arsenic have been employed in the treatment of several diseases, such as amoebic dysentery caused by microorganisms. Amoebic dysentery is a severe form of amoebiasis associated with stomach pain, bloody stools, poop, and fever. Rarely E. histolica invades the liver and forms an abscess, a collection of pus. Cholera spreads rapidly in areas where drinking water is contaminated. That was the problem for those on the Oregon Trail, just as it was in Haiti. Dysentery is also a diarrheal illness and is often caused by the Shilgus species, bacillary dysentery, or Entamoeba histolica, amoebic dysentery. So here we have amoebobiasis, also called amoebic dysentery. Amoebobiasis, a parasitic infection of the colon with the amoeba, Entamoeba histolica. Amoebobiasis infection is the most common in tropical areas with untreated water. It spreads through drinking or eating uncooked food such as fruit that may have been washed in contaminated local water. If symptoms occur, they may be mild and include cramping and diarrhea. Bloody stools, fever, and rarely liver abscesses may occur in severe cases. Treatment includes antibiotics. It's rare, fewer than 200,000 US cases per year. It's treatable by a medical professional. It requires a medical diagnosis. Lab tests or imaging are often required. It spreads through contaminated food or water. So again, arsenic is used to treat dysentery, which is a good thing. So arsenic is used to treat dysentery. Dysentery affected many people in the Oregon Trail. Cholera spreads rapidly in areas where drinking water is contaminated. That was a problem for those on the Oregon Trail, just as it was in Haiti. Dysentery is also a diarrheal illness and is often caused by the Shigella species, bacillary dysentery, or Entamoeba histolica, amoebic dysentery. So let's continue with the element arsenic. So arsenic, occurrence, and distribution. The abundance of arsenic in Earth's crust is about 5 grams per ton. The cosmic abundance is estimated to be about 4 atoms per million atoms of silicon. The element is widely distributed, so a small amount exists in the native state in 80 to 98% purity, generally in association with such metals as antimony and silver. Most, however, is combined in more than 150 different minerals as sulfides, arsenides, sulfur arsenides, and arsenites. Arsenic 72, 74, and 76 have been used in medical diagnostic procedures because they're radioactive. There's only one stable isotope of arsenic, and that's arsenic 75. It occurs in nature. The half-life of arsenic 76 is 26.261 hours according to Wolfram Alpha. So, Miss Pickle or arsenopyrite, Fe, A, little s, capital capital S, is among the most common of arsenic-bearing minerals. Others are relgar, As4, S4, orpiment, As2, S3, lowlingite, Fe, As2, and Cu3, As, S4. Arsenic oxide is also common. Most commercial arsenic is recovered as a byproduct of smelting copper, Cu, lead, Pb, cobalt, Co, and gold ores, Au. So here we have cobalt. It's a chemical element. Cobalt is a chemical element with the symbol Co and atomic number 27. Like nickel, cobalt is found in the Earth's crust, only in a chemically combined form, save for small deposits found in alloys of natural meteoritic iron. The free element produced by reductive smelting is a hard, lustrous, silver-gray metal, according to Wikipedia. Its symbol is Co, its atomic number is 27, its electron configuration is Ar3d7. For S2, its atomic mass is 58.933195 its melting point is 2,723 degrees Fahrenheit or 1,495 degrees Celsius. It was discovered in 1735 and its neutrons are 33. So here we have copper. It's a chemical element with the symbol Cu, Latin cuprum, and atomic number 29. It is a soft, malleable, and ductile metal with very high thermal and electrical conductivity. Its symbol is Cu from Latin cuprum. Its electroresistivity, thermal expansion, and thermal conductivity are presented below. So what is cosmic abundance? Cosmic abundance tables of the chemical elements provide the basic data for theories of cosmochemistry and nuclear astrophysics. The abundances are based on a variety of terrestrial, meteoritic, solar, stellar, and cosmic ray data. So hydrogen is the most abundant element in the universe, accounting for about 75% of its normal matter, and was created in the Big Bang. Helium is an element usually in the form of a gas that consists of a nucleus of 2 protons and 2 neutrons surrounded by 2 electrons. So the half-life of a radioactive isotope is the amount of time it takes for 1/2 of the radioactive isotope to decay. The half-life of a specific radioactive isotope is constant. It is unaffected by conditions and is independent of the initial amount of that isotope. So what is smelting? Smelting is a process of applying heat to ore in order to extract a base metal. It is a form of extractive metallurgy. It is used to extract many metals from their ores, including silver, iron, copper, and their base metals, according to Wikipedia. So that was arsenic explained in 35 minutes or less. We're back on track. The next video will be on iodine. Stay tuned for that one. I will continue making these videos in the following month of November and December. If you guys like this video, make sure to like, comment, subscribe. Oh, and also a quick reminder, arsenic is dangerous as an element, so be careful how you use it and be careful how you utilize this knowledge because it's strictly referential. Other than that, thank you guys for watching. Have a great one.